We're going to talk about precedence tables to graphs. We might even go back the other way, graphs to precedence tables. And this is all part of scheduling problems. Precedence tables, that's one of these things, and that's what we're going to talk about. So what's a precedence table? It's basically about what comes first. That's what precedence kind of means, what comes first. All right, and so you can imagine, like, you've got a bunch of activities and you're building a house. Well, activity A is the first activity, and there's nothing you have to do before you start activity A. So it might be the foundations of a house. You don't have to do anything, you start with the foundations. But maybe you need to build the walls. You can't do that until you've done A. So once A is finished, you can then start B. And maybe you want to build the roof. Well, you can't do anything about the roof until you've built the walls. So you can see there's a logical sequence to this. Directly before you build the roof, you got to have the walls done. Before you build the walls, you got to have the foundations done. And the foundations are where you start. Now, important to note on these kind of graphs is that they are activities are the edges. Now, these kind of graphs, they're also directed graphs, which means we need to have arrows. So they're directed graphs when we're doing these things. All right, now in the book, they tend to work backwards. I think you can go backwards or forwards. I like to go forwards. I'm going to start at the start. Now, this dot is our starting point, and everything has to come out of that. All right, so we're going to label that the start. And if you look at the start, this is saying that A is the first thing that comes out of that. And so we only got one thing coming out. I'm just going to put it like that, a straight arrow like this, put a dot at the end, call that A. But if now that we've done A, we can do all of these three things. So there's three things that require A before them. So we can do B, C, and D. And we'll put a little dot on the end of these because I think that's okay for the moment. So we've done A, B, C, and D. We're just working our way down the table. You don't have to start at the top and go down to the bottom, especially when you do things later. We'll talk about dummies. It's sometimes easier to not do it that way. And so E goes to B, F goes to C, and G needs D. So from B, now that we've done B, we can do E. So let's do an arrow and say E. That's that one done. F needs C, and G comes from D. That's all done. But H here needs E, F, and G. So what we can actually do is bring them all together into one beautiful node. You can do bendy lines. It's okay to do bendy lines. Do an arrow, and that's H. So H is all working out there. And our last node to finish it off, funnily enough, is the finish. It's okay to have bendy lines in your diagrams. In real life, they have computer programs that do all this and neaten up the diagrams later and make them all look a bit more balanced and things like that. But let's have a look at what we mean by that precedence. So if I look at activity H, if I flow back through the arrows, H does need G and F and E. I'm flowing backwards through the arrows, and that makes sense, right? So if I was to say start at, if I was to look at F, well, F going back through the arrows just needed C as the immediate predecessor, going back one step there. That was fine. And let's do another one. Let's do B. If I flow backwards through B, the only backwards arrow going backwards is A. So we've done our table all okay. And that's how you take a precedence table and make it into a directed graph where the activities are edges. Now, the big no-no in drawing these graphs is having a situation like this where you've got A and B. That's a case of multiple edges, yes? So you're not allowed this. So if you're wondering what all that early theory was you did, there was a reason for it. You can't have multiple edges in your graphs. That gives you two options. Option one is we go like this, and then we go, this is activity A, We don't do anything with activity B, we just leave activity B alone. And then we do dot like this, and we call this a dummy. Now, sometimes it's just a little d. They don't write the whole word dummy. It's kind of sometimes hard to put in the graph. But you could also have done, and both of these are equally valid and will not stuff up your calculations. You could have done A just going straight across and B going down like this. There's B. If I learn to, let's just fix that up. Students have been complaining about my handwriting lately. Love them, it's great. So there's the dummy, and either of those situations is okay, and that fixes the problem of multiple edges. Now a dummy has a value of 0, so dummies equal 0. They have no weight, so no weight. All right, so they're kind of just like a special magic way of fixing things, which is not often what you say about dummies, that they magically fix things. You think it's the opposite. Okay, let's start with our start node because we're doing table to graph, and we might end up a situation with the dummies here. So from that start, where there's nothing before it, we've got A and B. So just going to go like this. There's A, there's B. All right, done. Now, C comes from A. I can do that quite easily. Let's do that as C. And then D comes from B. All right, so far so good. Now, if we look here, we've got C, D, and C. I would rather, when you're doing these things, focus not going down the table, but this one first because it's only got the one letter. And I think that tends to work better. All right, so from C, we need F. So I'm going to do a line like that. I'm going to do another one like this, and I'm going to call that F. Now, E needs both C and D. Now, if I take D and put it up here and go like this, and then have an arrow coming off like this, and have E, you go, oh, that's all good. That means a bit of a bendy arrow, but it's not, because if you follow F back, you can go backwards through C and D, and F only has C, so we're not allowed to do that. All right, so all of that, let's try another way of looking at this. What if I do my node like this and have E coming off here? I've done F, and I can do a dummy feeding in there. All right, now let's just double check that this all makes sense, because we said that F, if you follow F back, you only go through C. You can't go down D, because we're going backwards through the arrows, backwards, backwards, backwards. So we can't do that. All right, lots of little dots there. But if I look at E, I go backwards against the arrow. I'm also going backwards against this arrow. Remember, the dummy has no weight, so you ignore it and then you go to C and back to D. So that's actually telling us we do actually have C and D. That does actually work. Isn't that nice? So my tip is always, if you're doing my technique, do the C because it only had the one thing, and then try and make the one with C and D more than one thing work next. And then the last thing we've got to do, because we've done now those two, is G, which has E and F, which means E and F must join up like so. There's your G, there's your finish. Look, it's not going to be a work of art. So if you're picking on my drawing, remember for some of you, I'm going to be marking your sack. So be careful what you pick on. All right, let's go backwards. Let's go graph to precedence table. So we got activity. I'm going to write IP for immediate predecessor. If you look, we've got A, B, C, D, F, G. So A, B, C, D, E, F, G. And I'm just going to grab my highlighter pen. Let's have a look at this. A and B have no immediate predecessors. That's pretty straightforward. A, and B. Let's have a look at, so C going backwards on the arrow goes back to A. That's it. So C only has A. D going backwards on the arrow backwards to A. We can't go down C because that's going forwards. That's wrong. So it's just A. If we then look at E though, if you go to E, flowing into, going backwards against the arrows is B and C. So you got B and C. Oops, thought I hit the eraser button. Let's look at F. F only has D. And G only has E. And we're all done. Let's do one more for the fun of it, because, you know, we all do maths for fun. So we've got activities, we've got A, I, P. All right, what letters we got? We go all the way to H, so A, B, C, call it act, D, E, F, G, H. That's where we're stopping. All right, A and B both go into the start, so that A and B. Let's follow C. So C goes to A, that's fine. Doesn't go through D because D is going the other way with the arrows. We're going backwards through the diagram. D goes to A. That's okay. Oh, good. Yes. Nothing funny yet. Let's look at E. Now E goes to D. Dummy doesn't count. Goes to B. So this one for E has D and B. We went backwards through the dummy. The dummy has no weight. So if you go backwards through a dummy, go back one more step. All right. Then F has E and C flowing into it. So I'll put them in alphabetical order. Be nice. Didn't do that before. Then G has D and B. So they both got D and B there. All right. Got to make that nice and neat for the people in the comment section. And what have we got left? H has just got B. If you go up the dummy, you're going wrong because you're going with the dummy. You're going backwards against the thing. So that's why we have that strange version of the dummy because of that. And that should be okay. Now, looking at past exams, there aren't actually many situations where they actually require you to use a precedence table to build a graph. This question actually wants you to work out the minimum completion time for this project, which is actually covered in the next video. So bye-bye to that. But what we'll try and do is actually use that table to draw the graph at least. Now I've had to shrink this down a bit, so I've got plenty of room to draw the graph. We'll start with the start as always. So start. And this time we're going to add also these things. They call them duration, that's kind of weight. So we'll put those on the graph. Now we've only got one activity that has no predecessors, that's A. So we can just do a straight line like this. Put our arrow on, and we're going to say A, comma 4. The 4 is for that duration. So we're adding the weights. It was worth the wait. Now, if we look at the next thing, the things we can draw these three with A. So that's B, C, and D. So we're going to have three things come off here. So we're going to have B, comma 3, C, comma 7, and D, comma 2. And then they're all done. And then we just scan down the thing. It looks like it's not too bad because we've got B, C, and D. So from B, we've got E. So we just go straight across like that. And that's E, comma 5. Then we've got off C, we have F. So we can just do F, comma 2. And then I might regret putting those dots at the end. Now, H is what's coming off D. We're doing the single ones first. Remember, that was my trick. So H, comma 5. Now G needs E and F. So I do actually need to sort of, I can do that a bit. So E and F need to join together because it says here to make G. So that's G, comma 4. And then G and H are needed for I. So we can take the end of this one. It's hard to fit these things in. G and H, we're going to make a little teeny little I, and we get I, comma 3, and there's our finish. All right, not the prettiest thing in the world, but it does actually answer the question. And let's just double check that we have got all that right amongst all our mess. GH from I. So if I go from I go G and backwards through H. That is correct. That is what we wanted. Let's check the other sort of trickier one. EF gave me G. So if I go through G, I get E and F going backwards. Yes, that's true. It's not art class. As long as it's reasonably clear, you'll get your marks. H, D. So H gives H only backs into D. That is correct. I'm going to check with let's just check C, for instance. I'm going to check all of them. So C definitely goes into A and nothing else. So we're all good.